Hi, in this video, I wanted to talk to you about an application of transistors that sometimes is quite nice to know about. And the way I thought I can introduce this to you by using the multisim simulation that you can see on the screen. So take a look at this circuit here. This is a fairly straightforward non-inverting amplifier, right? So you have a 5 volt input going into the non-inverting terminal, and the inverting terminal is connected to the output. I have used the model for LM358 here from the multisim, and therefore I've connected plus and minus 15 to the power supplies. Now, if you want to know how much current the op-amp can source, that the op-amp can give out, okay, one of the things that you can do is you can connect a resistor here. And let's say if I connect the resistor to the output, what is going to happen? If I connect this resistance, where is the current going to go? So the current is, so if an output voltage is generated at this point, there will be a current through this 1 kilo ohm, right? And where is that current going to come from? It cannot come from the inverting pin because the current into the inverting pin is almost equal to zero. So it has to come from the output of the op amp. So we can kind of figure out what is the limit of the current that the op amp can give by doing this. Okay, so let's do that. So what I'm going to do is I'm going to put a voltage probe here, and in addition I'm also going to put a current probe so that we can measure how much current is going in here. Okay, so let me run this. So if I run this, you can see that it's around 5 milliamperes of current flowing through 1 kilo ohms, and the voltage output is 5 volts, which is what you expect, right? Because this is a voltage buffer, the input is 5 volts, you get enough 5 volt output. Now let's increase the current that you're taking here. So let's say you make it, so I'm just going to, just to save time, I'll just make it 100 ohms. But if you want, you can try out with resistors in between. So I'll just reduce it by 100 times. And now you're getting like 40 milliamperes of current. But you can see that this voltage is no longer 5 volts. And why is it not 5 volts? Because the op amp is not able to supply 41 milliamperes of current through the output. So the voltage is dropping down. If I still reduce this resistance, let's say to 10 ohms, okay, yeah. So now, even now, the current is not going above 41 milliamperes. In fact, the voltage has dropped down, right? So instead of, so the voltage has dropped down to 410 millivolts, even though it should have been 5 volts. So you can see that this load is now loading the op amp. The op amp is not able to supply enough current. And you know why it doesn't supply enough current, right? You know the idea of output impedance that we talked about already. Okay, now what I want to talk to you about is how a transistor can help in supplying the additional current that is required. So let's take a look at this. So this is a very similar circuit, okay? And what I've done is at the output, I've connected a transistor here, and the load is now connected at the output, at the emitter of the transistor, okay? And what I'm going to do is I'm going to, okay, let me stop my simulation because I want to change certain things. So I'm going to put the current here. We'll see how much current is being supplied by the op amp, and some of the current which is going into the output, some of the current is going to come from the output of the op amp, but some of it will come from this power supply through this transistor. Okay, so let's take a look how this works. So I'm going to put the voltage probe here. uh, Let me try to move the current probe a little bit ahead so that we can see the values clearly. Okay, now let's just go to 1 kilo ohm to start off with, and let's run this. So the voltage here is 4.814, but that's not the voltage output now. Okay, I need to stop this, and let's put this at this place. That's the output voltage, because that's the place where the probe is connected, where the resistor is connected, right? So Okay, so you have got 5 volts here and you've got 5 milliamperes of current, and you can take a look how much current is coming through the base. Only 49 microamperes. So even though 5 milliamperes is being supplied to the load, most of the current is coming from here instead of from here, right? Does that make sense? Okay, now let's reduce the resistance here and let's make it 100 ohms. So now you have 49 milliamperes here and this voltage is still 5 volts. This current changes to 494 microamperes, which is like zero point 0.4, 0.5 millivolts. And the current, this circuit is able to supply the enough current, right? Reduce the resistance a little bit more and you will see it is still being able to supply, because still this voltage is still 5 volts. It's so the op amp is doing its job by giving 5 volts output even at this stage. Let's try to reduce this further by 10 times. And you can see now the voltage starts to drop. 4.1 the voltage has become. So we have improved the current capacity. So the current output of the op amp here was like around 40 milliamperes or so. And here this circuit along with this transistor is able to supply almost 4 amperes of current. So you're getting kind of 100 times increase in the current capacity of your circuit. So this kind of use of the transistor is called a current driver. So here we are using the transistor to increase the current capacity, to improve the current capability of the op amp. And the function of the transistor is basically to supply more current. Okay, so I just thought that this is an interesting application that you should know about. Sometimes when you want to use an op amp to output more current, this could be a very good way of doing it. I'll put a link to this multisim file on Moodle, and if you want, you can play around, change parameters, and look at this circuit a little bit more.